Problem 47 looks at the manufacturing of glassware. Glass stems are sealed by heating them in a flame. The temperature of the flame varies a bit. We are given a distribution of the temperature X measured in degrees Celsius. So we have temperature, and then we also have its associated probabilities. In part A, we want to find the mean temperature and the standard deviation for this random variable. So in list 1 in my calculator, I put the temperatures. In list 2, I put their corresponding probabilities. Then I went to my 1var stats and calculated the 1var stats on list 1 with a frequency of list 2. The values that popped up for me gave me this mean of X at 550 degrees Celsius and the standard deviation at about 5.7 degrees Celsius. So that first part's really just some calculator practice. Part B tells us our target temperature is actually the mean, 550 degrees. What we want to now do is think about how we can re-express our random variable so that it tells us how many degrees off target we are. Since our goal is 550, taking our random variable value x and subtracting 550 from it, that will tell us how many degrees off we are. So the mean of that distribution, the mean of x minus 550, is the mean of x itself, which is 550, lots of 550s going on, minus 550, and not hard to tell, that's going to be 0 degrees Celsius. And so thinking about the context of the problem, this is good news because it tells us that our average at least is going to be on target. We're going to be 0 degrees off. Now, in terms of the standard deviation, to find the standard deviation of this distribution, we need to know or revisit our rules for variances and standard deviations and linear transformations. Because we are adding, or in this case subtracting, a constant value from our standard deviation, this will have no impact on the variability. So that minus 550 really doesn't matter at all. Our mean, or our standard deviation, will still be our original standard deviation from the initial distribution. And so that will be our 5.7009 degrees Celsius. So for this new random variable, x minus 550, we have a mean of 0 and a standard deviation of 5.7009. In part C, we're going to do another type of linear transformation. Instead of looking at how far off target we are, we're going to look at our degrees in Celsius and convert them into Fahrenheit. So Y is going to be our random variable for the temperature in degrees Fahrenheit. You should notice or recognize this common conversion for Celsius and Fahrenheit here, 9/5 x plus 32. So in order to find the mean, as is with many of the cases, it's going to just be applied directly, taking 9/5 times the original mean, 550 degrees, then add 32 to that. When I type that in my calculator, I will get 1,222 degrees Fahrenheit. So that's pretty hot. In terms of our standard deviation, again, we have the same linear transformation, 9/5 x plus 32, but similar to part B, adding or subtracting that constant has no impact on the variability. So this problem can be simplified to just sigma sub 9/5 x, which is 9/5 sigma of x. So we'll take 9/5 times our original variability, multiply for our final answer of about 10 degrees. And there's our standard deviation, and there's our mean in terms of Fahrenheit.